Welcome to another episode of AP Computer Science. Make sure to have your writing utensils handy. ArrayList, part of the Java list collection, was introduced in Lesson 15. This lesson will cover the list interface and two different implementations of lists, ArrayList and LinkedList. Iterators will be covered as well as the different methods of storage used by the two implementations. The AP subset of Java list interface is shown. In order to implement a list, you must use the methods listed in the interface. Like ArrayList and other collection classes, LinkedList stores references to objects. This code creates class list as a list implemented as a linked list. Declaring class list as a list restricts the methods for class list to those in the list interface. The ArrayList class.util.ArrayList provides the following methods in addition to the list methods. If you don't quite remember how to use these, look back at Lesson 15. The LinkedList class is based on the LinkedList data structure, just as the ArrayList class is based on the array data structure. An array is a random access data structure of continuous elements. Any element in an array can be accessed directly by using an index. In a linked list, these elements are not connected by links and are not necessarily continuous. Also in a linked list, the elements cannot be accessed directly. The elements must be accessed sequentially, following the links until the desired element is reached. A good analogy for an array is the viewing of a DVD. Any scene in a movie on a DVD can be accessed directly using the DVD screen selection to jump to a scene. In contrast, playing a video cassette tape is an example of a linked list. To reach the scene with a VCR, the tape must be advanced through all the previous scenes. Some high-end VCRs have a feature that automatically goes back and marks the beginning of the end of each commercial of a recorded program. Then, when playing the tape, the VCR fast-forwards over the ads to skip them. To the user, it appears that the VCR is accessing the marked positions directly. However, the VCR internally sequences through tape commercials to reach the marked positions. This is similar to what happens in a linked list when accessing an element by an index. The LinkedList class, java.util.LinkedList, provides the following methods in addition to list methods. To declare a reference variable for a linked list, do the following. An object can be declared as a list and create a linked list or an array list. In either case, only the methods of list are available to the object. The advantage is that either implementation can be chosen without having to change any of the code that uses the object. Notice that the for each loop can be used here. A for each loop can be used in any collection that implements iterable. A transversal of a list is an operation that visits all the elements in a list in sequence and performs some operation. An iterator is an object associated with the list. When an iterator is created, it points to the specific element in the list, usually the first. The iterator provides the method to check whether there are more elements to be visited, to obtain the next element, and to remove the current element. This makes it easy to transverse a list. Using an iterator helps prevent off-by-one errors because the iterator knows how big the list is. In Java, iterators are defined by the util interface, java.util.iterator. Iterator defines the three basic methods. Object next returns the next element in the iteration. Boolean hasNext returns true if the iteration has more elements. Void removes the last element returned by next from the list. A list transversal will be implemented using the iterator as follows. Note that the list provides the iterator. A limitation of the iterator's interface is that an iterator always starts at the beginning of the list and can only move forward. A more comprehensive list iterator object is returned by list operator method. List iterator extends iterator. A list iterator can start at any specified point in the list and can proceed forward or backwards. Some useful list iterator methods are: object next returns the next element in the iteration. Void add object x inserts the argument into the list being iterated over. Void set object x replaces the last element returned by next by the argument. The following example illustrates some of the advantages of iterators. In example 1, the index is external to the list. So after removing Anna, I is incremented, but the elements in the list have changed positions, and Betsy is skipped. In example 2, the iterator keeps track of the positions of the element after Anna is removed, after Anne is removed and Betsy is not skipped. An important aspect of good programming is to choose the best data structure to solve a particular program. Here are some advantages and disadvantages of using linked list versus array list. Searching. Linked list best performance is ON because the list must be searched sequentially even if it is in order. Array list's best performance is ON because the list must be searched sequentially even if it's in order. Insertion or deletion. Linked list performance is O1 no matter how big the list is. At most, 2 elements are affected. Array list performance is ON because many elements of the list have to be moved. Accessing by index. Linked list performance is ON. Array list performance is O1. When designing a program to build a telephone directory, for example, array list might be a better choice than linked list. A directory would not change often, so insertion and deletion is not a major concern. However, fast searching would be important. On the other hand, linked list might be better for a print spooler program. Print jobs will be frequently inserted when received and deleted when the print job is sent to the physical printer. The list could even be prioritized so that small print jobs would be inserted near the front of the list. However, searching through the list for a particular print job would not be a common occurrence. Java provides 2 implementations of the list interface, array and linked list. Both implementations allow the program to use the standard methods of lists, as well as to take the advantage of methods specified for each implementation. Iterators are useful for traversing lists, and each implementation of the list has advantages that will make it suited for different tasks. And that's all I have for today. Now go code.